last December, I went to a concert of around 4,000 people in San Jose. I enjoyed the performance so much that I took short video clips and tried to share those with my friends. But none of them went through. Even I could not send my text message to my friends. So what happened? What's the problem? So I believe we are all mobile users, that we have experienced similar things. So what happened to this? If you look at the larger picture, by January 2020, there are as many as 8 million mobile devices connected to the network, and the global monthly mobile traffic is 40 EB, which is doubling every 2 years. To counter this challenge, the mobile operators are going to increase the number of base stations to as many as 16 million by 2025, of which 50% would be 5G base stations. COVID-19 is also contributing to this situation because many of the in-person communication have to switch to online. So our project 5G Coverage Dynamics is going to help mobile operators to optimize their network operations by monitoring the real-time network latency and predict user density and traffic.
So our approach is to capture the dynamic data like the latency, location, motion, and time of users, as well as the environment factors like the weather and the operation data from other apps like Yap. In reality, the provider can capture this data using the touch points of 5G antenna and do edge computing. In our case, we do the computation, we collect the data from to the Firebase, do the computation, and the output it to the web analytics platform. Then I will show our mobile demo. So in this demo, we store app on the user, and the app will keep track the location and the motion data, the connection type. And sending the data to our database. This is a real-time Firebase database. It keeps collecting the dynamic data from user. And we can see the data includes the provider's name, the type, the connection type of the network, and the latency, and the location, and other motion data.
First, we'll show you guys the browser app demo, in which case we implement the Google backend API where we monitor the user density on the Berkeley campus. As you can see from this video, there's different points regarding the user density. And as you can see, the area of the circle, especially the red area, would represent the latency for that particular location. So the greater the area of the red circle inside, which means the latency will reach a greater quantity. And with regards to the analytics portion of our technology infrastructure, we first took the approach of network latency prediction. And through that process, we sampled different locations on Berkeley campus where students are most likely to be condensing those locations. And after gathering those data, we removed the weekly trend and seasonality from those data and implemented this ARIMA model. As we can see from the graph here, there is seemingly a weekly trend for higher user usage and greater latency during weekdays, but lower user usage of the 5G service during weekends. So based on those data, we tuned parameters within the ARIMA model and obtained at around a 79% model accuracy, as you can see from this graph. So for the approach 2, we move on to estimate the user trajectory. And here we sampled 10 user data points in 3D spaces, which are longitude, latitude, and elevation. And this idea is based on the backend technology of Markov chain. So where we're able to estimate the probability of the user's movement based on the user's current speed, acceleration, and the user's current position. And through this modeling, we are able to segregate these 3D spaces into several categories so that we could predict user density within a confined space.
Yes, as you have learned so far that our 5G coverage dynamics project is operations oriented and data driven. So the challenges are primarily two aspects. One is from data acquisition. We identify two major sources of data from mobile devices and collect location, motion, and net connection type. Another major source should be the base stations from which we can get a more accurate latency and signal strength and even capacity data. And the second aspect of this challenge is that we want to come up with valuable analytics. Given the randomness of user behaviors, it is very difficult, but we find out that if we include more local information, like at Berkeley, if we include the course schedule, we will come up with better prediction. And we also think that this is a very good area to explore to customize network surveys.
So I'm going to talk about the learning paths for our project. So during week 1 to 2, we were primarily focusing on starting our idea, which we focused on IoT tracking. And after several rounds of interview with the freight industry and with professors in the IOR department at Berkeley here, we discovered that the 4G and Wi-Fi have already provided a viable and mature solution to the tracking issue. Then moving onward, we implemented a different project backend space, and we moved from our the latency prediction idea, which was location based, and after understanding the needs for the telecom industry, we moved from location based to user based idea, where we were able to track user trajectory and integrate this project with several different sectors, from the database, from the UI and analytics point, and to continue building our product. Then moving on to week 5 and 6, we integrate different parts where we automated the data collection process and perform an analysis on the backend structure and the front-end UI. We're able to construct this data-centric platform where we incorporated personalized user features and environmental stimulus to provide user with a great 5G experience. We're going to implement this agile sprint where we will set short-term technical goals to enhance our infrastructure. And with regards to our business and marketing goals, we plan to form partnerships with other events, apps, or services to improve their event planning. For example, we can cooperate with firms like Facebook Events or Eventbrite so that we can help their users to improve the 5G experience and when they're at those events. In summary, our 5G operator can leverage the AI system by avoiding the user to heavily depend on the infrastructure and help telecom companies to improve their ROI. And secondly, we can help to improve user satisfaction by reducing the latency and improving the 5G coverage. And lastly, we're able to innovate the service portfolios based on individual users' needs. And that will conclude our project.